Hello everyone. In this lecture, I am going to discuss about the signal flow graph. So, what is the signal flow graph? Basically, so for complex block diagram systems, the reduction is cumbersome and difficult to complete. So, this is the alternative method for reduction of the block diagram. So, it is a graphical representation to show the relationship between the system variables. So, and it does not require any reduction because there is a graph gain formula which is given by the SJ Masons. So, what is the property of this signal flow graph? This is the obtained from the block diagram of a system, and it is also obtained from the system equations directly. If a system equation is given to you, then you can directly draw the block diagram, and after getting the you can directly draw the signal flow graph, and after getting the signal flow graph, you can easily tell the transfer function for the given system. So, in this signal flow graph, the equation must be in algebraic form, and this Mason's gain formula or signal flow graph is applicable only for the linear systems. So, what are the components of the signal flow graph? So, components are node, branch. What is a node? Node is a system variable which is equal to the sum of all incoming signals at the node. What is a branch? A signal travels along a branch from one node to another node in the direction indicated by the branch arrow, and each branch has a finite gain. The signal passing through a branch gets multiplied by its gain. Suppose a signal flow graph is given like this. This is called node and this is called branch. A signal travels from one node to another node and it is connected through a branch. So, there will be some gain of this branch, and if I want to get the transfer function between this and this node, then this gain of this branch and gain of this branch will be multiplied. What are the terminologies used in the signal flow graph? So, input node or source node. So, what is the input node? Input node is a node which is having only outgoing branches. What is the output node? Output node is a node which is having only incoming branches. What is the path? It is a traversal of connected branches in the direction of branch arrows, and no node is traversed more than once. So, I mean to say, what is the path? Suppose this is node 1, this is node 2. The path is traveling from node 1 to node 2 is this. Suppose there is a node 3, then this is the path from node 2 to node 3. I can't say that between node 1 and node 3 there is a direct path. So, no node is traversed more than once. If node is traversed more than once, then it will become a loop. So, you can travel only one time only one time a node. What is a forward path? A path from input to output node is known as forward path. What is a feedback path? Feedback path is a path originates and terminates at the same node. What is a self loop? A loop that consists of only one node. And what is the path gain? The product of the branches encountered in traversing a path is called a path gain. So, these are the terminologies used in this signal flow graph. Input node is also known as source node. Output node is also known as sink node. Input node is a node which is having only outgoing branches. Output node is a node which is having only incoming branches. Path, it is the traversal of connected branches in the direction of branch arrows. Forward path, a path from input node to output node, and feedback path is a path originates and terminates at the same node. What do you mean by this? Feedback path is that it originates and terminates at the same node. Self loop, a loop that consists of only one node, and path gain is the product of the branch encountered in traversing a path is called a path gain. Now coming to the Mason's gain formula. The purpose of Mason's gain formula is to find the gain, overall gain of the signal flow graph, or you can say the transfer function of the system. It is mathematically you can represent transfer function is equal to summation of k is equal to 1 to n pk delta k upon delta, where pk is the path gain of the kth forward path. So you have to find whenever the signal flow graph is given to you, you have to find number of forward paths available in the given system or given signal flow graph. N is a number of forward paths in the graph. Number of forward paths in the graph is n. Pk is the path gain of the kth forward path. So if there is, and here k is varying from 1 to n, if there are n is equal to 2, then how many paths will be there? P1 and P2. Delta is 1 minus, delta is determinant of the graph, and it is equal to 1 minus sum of all individual loop gains plus sum of gain product of all combinations of 2 non-touching loop minus sum of gain product of all combinations of 3 non-touching loop, and so on. Delta k is the value of the delta for the part of the graph not touching the forward path. So this is the Mason's gain formula, which is used for finding the transfer function or overall gain of the given system or signal flow graph. Now, how will you construct a signal flow graph? This is the output equation. You can see in this graph there are 6 nodes, y1, y2, y3, y4, y5 and y6. We want to write the equation for node 2. That is y2 is equal to incoming branch. This is the outgoing branch. I want to write expression for this node 2. So y2 will be equal to this node multiplied by the gain of the path. y1 a12, this will be equal to summation of all incoming branches. Incoming branches are 2. y4 a42 plus y1 a12. This is the equation for node 2 y2. Next is, again here are 6 nodes. I want to write here the equation for y3. What will be the equation for y3? y3 is equal to y2 a23 plus y5 a53. Now, you can see here, this is the incoming branch. So I can write here y4 is equal to a34 into y3. Next. Again, you can write here the incoming branches are y4 to y5. The incoming branches, path gain for incoming branch is a45 and the path gain for incoming branch here is a35. So y5 will be equal to y4 a45 and y3 a35. So y5 is equal to y4 a45 plus y3 a35. Similarly, we can write here y6 is equal to y5 a56. So in this way we can write the node equation in terms of different nodes, or you can say you can write the output equation in terms of input node and path gain. So what you have to do, you have to write the summation of all incoming branches will give the output at that particular node. Let us take an example. How many forward paths are there, how many loops are there, and how many non-touching loops are there. So you can see here number of forward path means you want the paths which is going from initial node or input node to the output node. So here you have to travel from x1 to x8. So what are the possible combinations of the paths available in the signal flow graph? So here you can see that from traveling from x1 to x8, I have only one path which will go from x1 to x8. That path is x1, x2, x3, x4, x5, x6, x7 and x8. So here number of forward path is 1. How many loops are there? So you can see here one loop is there, x3, x4, or you can say this is the path gain, this is CD. So one loop is there, another loop is this. This is coming to the means in initial and initial point of the loop and terminated and end point of the loop is same, or the path is terminating at the same point from where it has been initiated. So you can see here this is the path. Again the second loop is x1, x2, x3, x4, x5, x6, x2. So second loop is this. Again you can see here third loop is here. So third loop is x5. So path gain is this. So here number of loops is 3. How many two non-touching loops are there? So you have to identify here, as you have to see that how many loops are there which are non-touching in nature. So you can clearly see here that this loop and this loop is non-touching. So you can write here, if I write this is loop L1, this is loop L2 and this is loop L3. So two non-touching loop will be L1, L3. And you can see here L2 is touching this loop L3 because it includes the node x5. If I write the loop L2, loop L2 will be x2, x3, x4, x5, x6, x2. So it will include this x5. So L2 and L3 are touching. So only two non-touching loops, only one combination of two non-touching loop is available in this example. Let us take another example and we will find the transfer function of this signal flow graph. So here first of all you should know what is the Mason's gain formula. Mason's gain formula is this: transfer function or overall gain is equal to summation of k is equal to 1 to n tk delta k upon delta. So so what will be the, how many paths are available, how many forward paths are available? Only one forward path is available, that is I have denoted here by P1. This is forward path P. Forward path P1 is equal to G1, G2, G3, G4, G5. How many individual loops are here? I have denoted by L. I have denoted the individual loop by L. So how many individual loops are there? First loop is this. So this is L1 is equal to minus G1H1. You have to write here the gain of the loop. L2 is this minus G2H2. L3 is this minus G4H3. L4 is this minus G4, G5, H4. So these are the loops. These are 4 individual loops available in this example. How many two non-touching loops are there? So it is clearly this and this loop is non-touching. It means L1 and L3 is non-touching. L1 and L4 is non-touching. L2 and L3 is non-touching. L2 and L4 is non-touching. So there are 4 possible combinations of two non-touching loops. First is L1, L3. L1, L3 is minus G1, H1 minus G4, H4. So it means G1, H1, G4, H3 is the first combination of two non-touching loop. Second combination is L1, L4. So the second combination is this L1, L4. So the non-touching loop will be G1, H1, G4, G5, H4. Third combination is L2, L3. L2, L3 is minus G1, H1 minus G4, H3. And minus G2H2 minus G4H3. So it will be G2H2, G4H3. And the last combination is L2, L4. So you can see here, in this way we can find the individual loop, forward path and two non-touching loops. Similarly, we can find the 3 non-touching loop. Is there any combination of 3 non-touching loop? No, there is no combination of 3 non-touching loop because this and this loop is touching to each other. This and this loop is touching to each other. If I make a combination of this, this and this, then there is no possibility of getting 3 non-touching loop. So there is no 3 non-touching loop. Now we have to find the transfer function. So how will you find the transfer function? We have to use the Mason's gain formula for I have already find here P1 only n is equal to 1. So formula will be P1 delta 1 upon delta. So we have to find the value of delta 1. How will you find the value of delta 1? Delta 1 is equal to 1 minus sum of non-touching loop to that forward path. It means we are finding the value of delta 1, means we have to see how many loops are there which are not touching the forward path P1. So in this figure you can see there is no loop which is not touching the forward path P1. So it means you will write here delta 1 is equal to 1 minus 0. So delta 1 will be equal to 1. Now how will you find the value of delta? Delta is equal to 1 minus sum of individual loop. 1 minus sum of individual loop means 1 minus L1 plus L2 plus L3 plus L4. It has been written here L1 plus L2 plus L3 plus L4 plus sum of product of two non-touching loop. Sum of product of two non-touching loop I have already find here. There are 4 possible combinations. So you have to write the summation of all these combinations. This will give the value of delta. After getting the value of delta, you will put in the Mason's gain formula and you will get the transfer function. So this is the answer of the given question. Now coming to the next example, with the help of block diagram, with the help of signal flow graph, how will you reduce the transfer function using Mason's gain formula? How will you reduce the block diagram using Mason's gain formula? So you have to replace each forward path and each feedback path will be replaced by a simple path. Feedback gain and forward path, forward gain, feedback gain and forward gain. So I will put here arrow going from input to output. Gain for this path is GS. So I have written here GS. Now from YS to HS you are having the gain H. Here the negative feedback has been used, so I will use negative sign for the feedback path. Now how many nodes are here? I will replace here the summing point and the takeoff point by a node. So here is just one summing point and here is a one takeoff point. So these summing point and takeoff points will be replaced by a node. So I have replaced this summing point and takeoff point by a node. Similarly, you can see, you can consider this block diagram. So here you can see there are 3 summing point and 1 takeoff point, 2 takeoff point. There are 2 takeoff point, 3 summing point. So number of nodes will be 5. You can draw like this. U is the input. This is the node and this is the node. Between this and this node, G1 is the gain. So between this and this node, G1 is the gain. This takeoff point is connected between G1 and this takeoff point is connected between between the summing point and this block G1. So I have considered here another node which is going to this node, and this path is having gain of G3. So this is connected at a G3. Similarly, this node is connected to this takeoff point. So this node is connected to this takeoff point with gain H2. You have to write here minus H2. So this is minus H2. And similarly, this takeoff point is connected to this summing point with gain minus H1. So you can connect this with minus H1. Now you can find the forward path and feedback path. Number of forward path is G1, G2. First is G1, G2. Second is G1, G3. And no other path is available which is going from input to output. How many loops are there? One loop is there, G1, H1 minus G1, H1 is first path. G1, sorry, G1, G2, H1. G1, G2, H1 is the first loop. Second loop is this, G2, H2. Third loop is G1, G3, G1, G3, H. G1, G3, H2, G1, G3, H1. You can consider here G1, G3, G1, G3, H2, no, G1, G3, G1, G3, H1. This is G1, G3, H1, not G1, G3, H2. Now you can find delta 1 and delta 2. You have to see how many loops are not touching, how many loops are touching the forward path P1 and P2. So you can find that no loops are available which are not touching the forward path. So delta 1 will be equal to 1 and delta 2 will be equal to 1, and delta is equal to 1 minus sum of individual gain plus sum of product of two non-touching loop gain. So you can find the value of delta, and by putting in the Mason's gain formula you can find the value of P1 delta 1 plus P2 delta 2 upon delta. So this will give the transfer function for the given block diagram. In this way you can find the transfer function of the signal flow graph or overall gain of the given signal flow graph, or you can reduce the block diagram using Mason's gain formula by converting it into the signal flow graph.